Hey guys, welcome back to the channel. Have another ECM. This time just a test. This is a test after repair. This is a 1992 Ford Mustang 5.0. This is another computer I have actually, I think one a couple of weeks ago. I actually didn't fully record a video because I was actually waiting for the whole setup to be here, and now I can post a proper video doing the test on this. And as you can see, I got everything. I even bought a distributor. I have it instead of the coil because I don't like to put a coil, even though I have the ignition coil really here. And I bought this one for like a, Ford Escape or F-150. They're cheap, and but sparking in here, it can be damaging for my equipment. So I decided to just use, this is an IAC valve, which is a coil, right? So it's a solenoid valve that will open and close. And this is all we really need to make sure that this distributor or setup in the computer is able to produce a spark and also see the injector activation. Because I have right now 8 channels or going over to my simulator for all the 8 injectors. I got also the fiber reference and sensor ground connected over to my multimeter here, so we know that that is connected. And I also bought a breakout box for this setup. This is an 80 pin computer. Make sure I'm saying that right. 60 pin, sorry, 60 pin computer. So this is the EE4 breakout box. I just took it out of the box itself and I attach it over to my bench, and I can remove it and put it back into the case. It comes, this is just a plastic case, but I created a harness so I don't have to, because you can put like I'm doing here with injectors, things on the front, and this is the reason of the breakout box, so you can check all the signals, all the sensors and everything. And I will go over to the diagram of connections pretty shortly, and I want to show you that it's working perfectly. Right now this computer was no injection and no spark. It's very common on these computers, even though it looks like brand new computer. It wasn't working. So he's like, "Hey, Mike, can you please repair this? Is the third computer that they sent to us, and it's not working." I'm like, "Did you check the capacitors? Because it's the most common failure parts on these computers." And he's like, "Yes, they already replaced the capacitors. They cannot make it work, and I need a car. I really want to have this car running again, and I want to make sure that it's fixed." I'm like, "If I give it to you back, I will put a video so you can see your computer working." This is for Jim. He's also here local in Virginia. So Jim, this is your computer. As you see, I took the time to completely do the setup, so you will see your computer working 100%. All right, things that I have, because I also have the oscilloscope, 4 channels. So I have the yellow and the green connected over to the coil. Again, I'm using an IAC valve just as a substituted value, but it will create a spike almost like an injector. Um, the blue channel, I have it on the PIP because this is TFI 4 set up for Ford, and this is the tan or gray color module, ignition module ICM. You also have a black one, and the connections will be different. Even though you can do a bypass test, and Paul Danner, my good friend Paul Danner, has very good videos on this that you can, if you have it on the car, you can just put a T-pin behind here on the PIP. You will have a ground on one end, on I think it's pin 1, and then pin 6 is the pip. But we'll go on to the wire diagram in a second. Going back to the setup of the oscilloscope, the blue channel is on the pip, and the green channel is on the, sorry, let me just make sure I'm saying that. Sorry, the red channel is on the spout signal, which is coming from the computer to control the dwell and so on. For the rest, powers and grounds are pretty simple on this computer. And actually, this breakout box is really handy. Forget about, and not forget, sorry about the spaghetti. Again, I'm just finishing the setup and I'm very happy to share. I will have this routed into, a conduit like this, and something that will look very professional when I'm done with the system and I know that it's working good. Uh, Powers, pin 1 is keep alive power, then 37 and 57 in ignition feed. They are always, with ignition. Grounds, you need 40 and 60. 20 is a case ground and also works as a shield for the signals that comes over from the ignition module. So very important to have that one. You will have a ground supply by the computer for the ignition module coming on pin 16 from the computer. Another very important wire. If your distributor is not firing, make sure that you check the powers and grounds. And again, I will go over to the wiring in a second. All right, so now that we know the setup, I want to use, because I'm very happy to have this because I have that little bench in there. I'm actually supplying an extra ground, kind of like a chassis ground, let's say, for the distributor just in case. But I can rotate this in here. And as you can see right there, I got the injectors firing, so 8 injectors, and we can see the injector millisecond on the 8 injectors. I just stopped because my drill came out, but we can see that happening really, really good. So all the injectors are working. On the signals on the oscilloscope, let me stop this 1 second, and we can go back into the capture. I think yeah, I got plenty of time. So we will have again yellow, which should be power supply for the coil. So this is a steady voltage. It will have some drops obviously because we have a load in there, which is in the green channel. This is that IAC valve substituted value for the coil. You see it has almost a signature really close to an injector, and it reaches high voltage because if we can see the spikes, and I think it's still being clipped, are over 200 volts. And for that reason, I have an attenuator on that channel, very important because this is not an automotive oscilloscope. So let me raise the voltage to 400 and redo the capture. I can go into probably 20 milliseconds per division. So let me run the distributor again and the computer, right? So we can see the injection in there and we can see the response on there. So yeah, those spikes are reaching the 400 volts. All right, so let me again stop the capture. And this is why it's so important to use attenuators when you have such a high spikes. And I know I can put a diode in there online and then see exactly where we are as far as voltage. But I know that I am good because it is a very fast spike. So I'm going to turn channel uh, the let me just see the yellow channel off. Again, that's just voltage. We can either turn the other channel so we can analyze one at a time, right? Now that we have the capture, I can now bring these up, but you can see this is again almost like an injector waveform, pretty close to that, right? So we can see there is reaching the spikes over 400 volts and is being pulled down, which is at the end very important too, right? Almost to ground. So that is the way the design of this valve is. We can do a closer zoom so we can be more precise in there. But yeah, we can see that everything is working like 1.9 volts up to 400 and even higher than that. I don't think I could go higher. Yeah, 400 is the maximum I can go with this oscilloscope using an attenuator. All right, so that is again the coil. So let's turn this one off and we're going to see now channel A and B, which is again the spout and the pip. This is very unique from Ford. This distributor uses a Hall effect. So on this ignition module, we have 3 pins in here, power and ground, and then the signal. When the distributor turns, it has a window. Let me see if I have the picture here, which I think I do. As you all know me, I always try to gather all the information necessary to present and give you the correct information. So this is exactly how that looks. This window or reluctor, right? We can call the reluctor inside the distributor has 8 windows. One is small than the other one. These will show the number one piston. So when the computer sees that, it gives the correct firing for the injectors, which is very important. And that also makes a very unique signature. This is the wire diagrams. I found this online. This is from 88 to 91, but it's actually up to 92 because this is exactly the one I'm using and works perfect. In here we can see what I was saying about pin 20 case ground. You see What they're doing in here, the case ground is shielding the signals that come from the TFI signals over to the computer. These are very important on the car. They're not that important in here, obviously, because I don't have any noise that can be problematic. The reason they pull this shield is to keep the signals clean and reaching the computer. I did put a 22 kilo ohm resistors for this IDM line. It goes over to pin 4. This is a confirmation and also a tachometer signal if you have a tach, right? I already explained powers and grounds. If you need any help for this computer, I definitely can fix it 100%. Let me see what else I have as far as information. Actually, I got this capture from Paul. I stole it from one of his videos because I was looking to see a comparison because I needed to see exactly how high the voltage signal can go and then what am I expecting to see, right? So Paul Danner was very helpful. I also found these connectors. They call this salt and pepper for the injectors. This is on the car most definitely if you have any issues or problems. Let me see what else we have. Okay, the distributors. This is also where I was a little confused because there is multiple diagrams. Let me just see if I go over to E, A, B, C, D, E. Yeah. So there is different designs, and this is very important to talk about. Like in my case, I'm having sorry, as I was referring before, there is a gray and a black ignition module. This is for the black, and the reason I know that is there is a difference in between the coil and the 22 kilo ohm resistor. There is not in place if you have a black module on the car. Like we see, we have, let's say, pin 1, pin 2, pin 3, pin 4, pin 5, and pin 6. So PIP is always the pin 6. And the spout is the same. What it changes is the IDM. In the other version with the same distributor that I have here with a gray distributor, so let's look at signal that will be pin 1, 2, 3, 4. All right, so it says IDM in here. If I go up to the gray one, which is the first one here, and now we go 1, 2, 3, 4. It says a start. That is coming from the ignition switch, and it's a power only when you start. So you see the difference? Also, we have in place on the coil, again, a 22 kilo ohm resistor going over to pin 4, which is the IDM. On the black ignition module, you don't have that because IDM goes over to pin 4 on the computer. You see pin 4 IDM, pin 4 computer. So that is the difference that we have in there. Let me see if I'm missing anything else. Um, Let me see what else I want to share. I think I got all the connections in here. We have that. I got, I can help you with wire diagrams. I've been doing a lot of homework in here. This is the computer and alternator. I have also the ignition switch. And this is drawn by somebody else that took the time to make this because you cannot find this anywhere. Like the actual original diagrams, which I do have here as well, because I always like to compare information with the original diagrams. I found it on Identifix, and these are the original diagrams. So very hard to read sometimes the numbers. Even I was a little confused on the injectors until I found those um, colored, because if you see here, is this a 58 or a 56? And it's a little hard to read. So let me, what else? What else I have here? This is the same thing, another more information that I found about those signals and the Hall effects and how this is, very important if you want to read that and have a knowledge of how that goes. So we have the first pin is ground, the center is the 12 volt supply, and the last pin will be the PIP signal coming from the sorry, from that Hall effect, and then out to the computer, right? And this is the way that you can select, do a tachometer for your vehicle. All right, let's go over to the oscilloscope now that we have those two signals. And now I can measure the amplitude I can do. And I mean, we can definitely see the very unique signature, because you see how that is clip, and it's the same thing as in red is the spout, sorry, blue is the pip. There is another difference in the signals, and we will see that. Let me just see right here. So this is the number one, kind of like sync, remember, on the distributor, and we can see it here. So I'm going to just do a zoom in there. Let me take those lines out. Well, I need it, right? Sorry, guys, it's a little late. It's almost 9 p.m. and I'm always working hard, trying to help others and, stay as much as I can uh, on the time of the repairs too, right? But yeah, so if we measure now here, now that I have a window, so we have a small, then normal signal. So we should have 8 in between. So 1, 2, 3, 4, 5, 6, 7, and then it repeats. So 8. If I bring channel, the green channel, which is the coil, let me do that. We can bring the green channel. The firing should be happening right after, or in this case, before, because remember, we will have to like kind of like mash the closing, because this is being power on and then release and then close and release, right? So this is how that is working. So we can see that those are pretty much lining up with the commands of that distributor. So everything is working as it's supposed to. All right, guys, thank you so much for visiting the channel. I don't want to make this video too long, but yes, now that I have all this set up in here and I understand, because this is exactly what I want to do always before I jump into try to repair a computer. I need to reverse engineer the computer, but I need to understand 100% how the signals work. Then I know when I have a known good or a known bad and make everything work. So I'm very happy to have this set up, another good system that I can work on, because there is still a lot of these 1992s. Those are still used. People love this vehicle. So I am, you know what? I think this is a necessity, and I'm going to try to help this community. So if you have one of these forums, if you are part of these forums and you have problems with these computers, just send it over. You're in good hands. I will always record videos before and after. The reason I didn't do on this one before is because I was doing the setup, and I probably invested just on this setup that you see here. I don't know, maybe 20 hours doing the harnesses and putting the connections and soldering and everything. I still have to perform more time or use more time to make it look more decent and more professional for my desk, but everything is good. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.